Everybody, it's Tyler here at the Speedway event, checking in with 96504C Exotek, coming in from Tennessee. Already won the Hub City regional event as well too, so a great performance by them so far. We're going to be talking about some cool iterations on the robot. They have an awesome kicker mechanism, one of the fastest ones that I've seen from match load, so really cool with that. But we're going to talk about some sensors, some other great stuff that goes in this robot. Let's learn more about them coming up here on Pits and Parts.
This video on fun is brought to you by viewers like you and also in partnership with the following. The Robotics Education and Competition Foundation provides fantastic programs for students from elementary school all the way through college. These include VEX, aerial drone competition, online challenges, JROTC, girl-powered, scholarships, certifications, and so much more. To discover these exciting opportunities, visit recf.org and get connected. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/vex to learn more and apply.
Lucas, we got to start with the kicker mechanism in your robot. Watching your last match here, I hear you're so quick with that. Tell me about the composition of it and what's led to having such a quick match load strategy.
So this kicker features a double swip gear, and right here you can see it's got 1.5 motors actually, because when we saw that one wasn't enough, so we had to add on just an extra half motor right there. It fires at 133 shots per minute, about 2.2 tri-balls per second. And here, let me just demonstrate. Wait. Yeah, so that's our kicker mechanism. We've went through a whole bunch of iterations. Originally, we didn't actually have these metal parts right here, but we had to add them so that we could get the tri-ball placement consistent. That's really the hardest thing when dealing with like really fast kickers, is making sure that you have the tri-ball placement like down. So we've spent a lot of time practicing that. I think we've spent like upwards of like 20 hours at this point. So this is really just, I think, the best part of our robot. When
you were analyzing from that aspect, what came first? The fact that you can load that quickly, or did you make the mechanism first and say, let's see how quick we can load it?
It's kind of a combination of both. We started off already with a fast mechanism, and then we've kind of realized now that we can go faster. So in our next, version of the robot, we're going to probably feature something that goes up to maybe 150 or even higher, in shots per minute. So really, there's still a lot of room for improvement here. I think this is a great spot for a lot of teams to improve on, is just the pure speed that kickers can go at.
Very cool. Now, one other thing I want to ask in that, from the loading itself on there, so can we show where does the tri-ball actually load on that? Because getting it that quick on there, so it's just that snug essentially?
Yes, so we just kind of shove it on like this.
Gotcha.
And then, we have sensors here to detect when it's placed on. We'll get to those later. But it launches the tri-ball out. Can we demonstrate now, or should we? All right. Yep.
I love the overall thing. Let's talk about sensors on the robot, Anthony, and what's gone into that as well too. Of course, from an auto balance as well too. Love to hear about some cool things that are on your robot, and let's pass it off and hear more about it.
Yes, so while having an amazing kicker is great, programming also is a big factor. And so you can see this distance sensor located right here. We use no loops in our programming. It's all event-based. So when this tri-ball is placed down, that sensor will detect it and activate the kicker, as Luke can demonstrate. In addition to this, we also have an auto balance feature, which allows us during the in-game to hit one button on the controller, and it will automatically go and line up with the center point of the field and balance for us. The driver does not need to do any guesswork during that process.
So this is our elevation mechanism right here. Folds out like that with pneumatics, and our auto balance system, basically, it detects using those inertial sensors on the bottom that I think Anthony is going to get to later. It balances pretty much on the sidebar between these two back wheels, and it's been something we've been working on for a while.
Yeah, talk to me more about the sensors that go into that.
So if Luke would like to rotate the robot to its underside, you'll see that we have an inertial sensor, which we use in addition to PIDs, proportional interval derivatives. You can see the inertial sensor right here. We use this to correct for any inconsistencies with rotation and for that auto balance feature.
Something I ask you from your climber side, more of a mechanical question, I guess, but are you looking at doing anything higher as the game evolves as well, too, or have you been pretty happy with the level it's at?
We're pretty happy with this because we pair best with a team that does elevate high on the horizontal elevation bar, and only one robot can do that at a time. So I think there's a strategic advantage to being able to hang just from the side. It allows us to pair with alliance partners.
Yeah, a lot of versatility with that, right? Absolutely. Luke, I got to ask you while we have you. I know you really want to talk about zip ties on your robot, and that's something when we hear in prep, we're like, oh, okay, zip ties, but you promised me there's some functionality to it, so talk to me about it.
Yes, I promise. So these zip ties right here, they allow us to touch the match load bar, or at least have a much larger margin of error when we're touching the match load bar, so that way even when we're getting play defense on, we can still be touching the bar technically and still be able to match load. We also use zip ties at the front to touch the elevation bar, the horizontal one, for getting the wind point. These have worked really well. And then lastly, we use zip ties to activate our elevation mechanism. If you look closely here, you'll see it's only attached by zip ties. But we promise it does work, and if it makes you feel better, we have 2 zip ties for redundancy.
No, I love it. And sometimes simplicity is the best solution for many things, right, when we look at robots as well, too. That's super cool. A lot of great stuff about the robot, but I noticed you have a lot of these QR codes out here. Shonak, you got to tell me about the big QR code right in the middle of your robot here. Where does it lead to, and what's the initiative you have behind it?
Yeah, so when we first started out robotics, we were all in 6th grade. That was 7 years ago. And Vex Robotics, it was brand new, so we didn't have any guidance from senior members. So now that we're seniors, we created a registered nonprofit corporation dedicated to providing resources for newer Vex teams to learn about robotics, get started with it, how to build a robot, how to design, how to document, how to do good on interviews and engineering notebooks. So that's what we did here with the QR codes. We're trying to spread the word, get it out there, make sure people love robotics, learn about it, preach it.
Awesome. So make sure you check out the QR code on there. By the way, I just want to give a big compliment. It's so important to provide educational resources as a team to help inspire other teams as well, too. So congratulations on that. Congrats on a great robot as well, too. Exotek, once again, looking phenomenal here at Speedway. Looking for big things out of you here. Thanks a lot for taking time. Tell us about your team and your initiatives as well.
Yep. Thank you.
This video on fun is brought to you by viewers like you and also in partnership with the following. The Robotics Education and Competition Foundation provides fantastic programs for students from elementary school all the way through college. These include VEX, aerial drone competition, online challenges, JROTC, girl-powered, scholarships, certifications, and so much more. To discover these exciting opportunities, visit recf.org and get connected. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/vex to learn more and apply. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Most live shows can be found on the First Updates Now YouTube channel, live competitions at twitch.tv/firstupdatesnow, and join our Discord at discord.gg/firstupdatesnow. Check our other social offerings on TikTok, Instagram, Facebook, and Twitter.